After videos on linear regression and polynomial regression, in this video let's talk about gradient descent. Now before we proceed on to gradient descent, let's do a bit of recap. That is recap what is loss function, what is cost function. These are the concepts on which gradient descent works. Now loss function was the error I make on one particular exercise. Cost function is the error I make on all the exercises. If there were 4 exercises, then all 4 combined will give me a cost function. Now let's try to make less errors, and that is where the gradient descent will come in. That is, gradient descent will try and decrease the errors that I make. Over to next slide. Now, before we go into gradient descent, let's try and learn one more important concept which will be used in gradient descent. That is, we learn about learning rate. Learning rate is like a tap. You screw the tap, say, with 180 degree, that is half circle, and the water slows down. You screw the tap for one full circle and the water slows down again. So that is the learning rate, that is half screw or full screw, full circle or half circle, that is the learning rate. And the number of times you rotate the tap, that is the iteration. So obviously you can make out that if you turn the tap half circle, then more iteration will be needed. If you turn the tap full circle, then less iteration is required. This concept of learning rate will be used in gradient descent, and that is where learning rate, I have tried to explain learning rate with the example of a tap. Now let's see the graphical representation. Now this is the graphical representation of gradient descent. Initially that water was overflowing through the tap. So you see the initial weight, and we are trying to screw the tap. That is, we are trying to stop the water flow. And that is where less and less I am going on screwing, and in the next repetition the water flow decreases. Again I am screwing. Again I am turning full circle. I am turning the tap, and again the water flow decreases. Ultimately it stops. That is the local minima. That is the stoppage point. And the incremental step is actually the number of repetition. That is the iteration. And how much how much I turn the tap is the learning rate. This is the difference of having a small learning rate and the large learning rate. You see that if there is a small learning rate, that is on the left side, you turn the tap, say half circle or quarter circle, and you need more such turning, that is more such half circle or quarter circle to stop the water flow. That is the risk of having a small learning rate. That is, more number of iteration is required. On the contrary, if the large learning rate is there, it can have a risk of overshooting the stoppage point. That is the risk of having a large learning rate overshooting the stoppage point. After talking about what gradient descent is, let's talk about the types of gradient descent. Gradient descent is mainly of 3 types. That is, first is batch gradient descent, second is stochastic gradient descent, and third is mini batch gradient descent. Now let's see exactly what these are. Like I said previously, gradient descent is of three types, that is batch gradient descent, stochastic gradient descent, and many batch gradient descent. Here is majorly the difference majorly. That is batch gradient descent means the entire training set, entire data set I am taking for the problem. That is, I am doing the entire set of examples. If I have 10 examples in my book, then I am taking all the 10 examples for one problem to arrive at a solution. Now, stochastic gradient descent, what it does is it takes one example at a time and solves one question at a time. Say I have 10 examples, so it will take 10 times, it will take one example each. One example each it will take, and that will repeat for 10 times. That is stochastic gradient descent. And lastly, I have mini batch gradient descent. It is basically a mixture of both these two. That is all the good points of these two. That is, if I have 10 examples, it will take small chunks of maybe 2, 5 times. 5 times it will take two examples each, or maybe two times it will take five examples each to learn from the mistakes it does. So these are the three major types of gradient descent algorithm, that is Bayes gradient descent, entire training set, stochastic gradient descent, one training example at a time, and mini batch gradient descent is actually the small chunks of data at a time. These are the differences. Let's compare the three types of gradient descent that we learned earlier. So you see on the left you have gradient descent, the stochastic gradient descent that cannot be drawn, and mini batch gradient descent. You see how you have divided the entire batch into small batches, small chunks of data, and while doing a gradient descent, that is how it stops the water flow. That is, in case of batch gradient descent, it smoothly arrives at the lowest point. That is, water stops smoothly. In mini batch gradient descent, because it takes small chunks of data, the water actually stops. You see, the graph is actually a little haphazard. That is, the water is stopping, but a lot of labor goes into it. And lastly, you have the stochastic gradient descent, that is one example at a time. And you see there is lot of fluctuations in the data before it converges. You see there is lot of fluctuations. Below is a graph which says that the velocity is high in the stochastic gradient descent and mini batch gradient descent instead of batch gradient descent. Say suppose you have 1 million data to learn from, and you are doing the computation. So the fastest would be stochastic mini batch, and the slowest will be the batch because it's taking the entire 1 million data set. Now, in case of accuracy, you see that in case of stochastic gradient descent, there is very little negligible accuracy. That is because lot of dancing around, lot of fluctuations. On the contrary, mini batch and batch gradient descent, it gives me a lot of accuracy, and similarly with updates, you see that will stochastic gradient descent will actually update itself after every time it learns After every time one data from each data point it learns something. That is stochastic gradient descent. In case of mini batch gradient descent, it learns after each chunk is executed. And in case of batch gradient descent, it learns after the entire batch is over. That is, if the batch has 1 million data, you can understand from the graph that how much time it will take, how much accuracy will it happen, and how many times it will update itself. Thank you. That will be all for this video on gradient descent. Now, as always, there will be a poll on the channel community, and you need to take the poll within the first 7 days of publishing this video. And unless you suggest me something else within the first 7 days, I am going to go ahead with the next video on regularization. Thank you and have a nice day. Thank you.